Alright, this is my 8 puzzle implemented in Python. It consists of 2 classes, a puzzle itself and a node class. The node here is how I implemented the puzzle. Basically, it's represented as a vector of integers. Each index of the vector corresponds to one of the slates in the puzzle, and the operations are mathematical operations on that index. So basically, adding 1, subtracting 1 moves it left and right. Adding 3, subtracting 3 moves it up and down. And if those operations don't put that index out of bounds, then it is a valid action, and we pass the information corresponding to the child node generated by that action to our search functions. Now, the puzzle will take the user input for the correct search function, generate, if possible, a solution node, and then trace that node's path back to the start and print it all out for you. So here in the best first search, just start with your initial node, generate children, throw them onto the frontier, and get the first node from the start of the list, and repeat until you get to the end. Depth first search, exactly the same, only you get the most recent node instead. In the universal cost search, you actually have to start sorting through your frontier, and we just minimize the cost, sort it by that, and grab the one with the least cost to open up next. So our heuristic functions work pretty much the same way, just mathematical operations on the indices of the state list. You got your misplaced and your Manhattan. So for universal cost or greedy best first search, just sorts by whatever minimizes that, and pops that. And the A star is obviously a little more interesting. Here we're not going just by that heuristic. We have to calculate an F value based on both the cost and the heuristic. And the logic of this is a little more complicated, because if we arrive at a new node thanks to the modified, the fact that the paths cost different things, there's more than one way to get to a node, and if the way that you get to it is cheaper, then you have to put that node back in the frontier as a potential path. But this ensures that you'll always generate the most efficient path. It's pretty inefficient thanks to these guys, these searches. Alright, here's a quick demonstration. As you can see, it prompts you for input in the form of 9 numbers. It puts those into a list, and there you go. It displays a path, each step, the length, cost, time, and space.